This is the last day of marking period 1. In this marking period, we try to describe motion using ideas came from Aristotle 350 BC and ideas came from Galileo 1591. Next marking period, MP2, will try to explain motion using ideas came from Sir Isaac Newton. In this marking period, now I'm going to go over the test, the unit test, exam number 6. Problem number 1. So this is problem number 1. We can do a few different ways. I'm going to just quickly convert it to BT graph. I ask you at 3.5 seconds what would be the slope of the tangent line, and you can do it by a few different ways. This is your BT graph, and you know that from 0 to 2 seconds your velocity is 2 meter, and from 3 to 4 seconds your velocity is 0, and from 3 to 4 seconds you don't know your velocity because there are so many velocity, but at 4 seconds you know your velocity. This is 2, this is 3. At 4 seconds you know your velocity is 0. At 3 seconds your speed is maximum. At 5 seconds your speed is also maximum, right? So you have a diagonal line over here. So you know the slope, you know this one, this is 2, so the slope of this one is 2, the slope of this one is 0. Now we want to find the slope of this one, and that would be acceleration. Acceleration is 0 here, acceleration is 0 here. Now we want to find the acceleration over here. So this is, we know this is area, so area is half BC because this is a triangle, and area is displacement half, b is of course time, and h is velocity. So d is, of course, you have 8 minus 4, which is 4, half. T is 4 minus 3, which is 1. Velocity, multiply both sides by 2, so the velocity is 8, right? So if this velocity is 8, final velocity has to be also 8, right? The final velocity also has to be negative 8. Okay, good. So now we have 2 points. Point 1 is 3 comma 8, and point 2 is 5 comma negative 8. So we can go ahead and quickly graph AT, right? AT. So the slope of this one is 0. The slope of this one is 0. Let's change the color. Slope of this one is 0, right? Slope of this one is also 0. Slope of this one, we can say negative 8 minus 8 divided by 5 minus 3. So is negative 8. Okay, so it's negative 8 from 3 to 5 seconds. Acceleration is negative 8. So this is negative 8. We probably don't need it. We can, because I ask you to find the slope of this tangent line when the time is 3.5. That means all you need to do is use the midpoint, or maybe you can use this equation VF plus VI over 2. So VF is of course 8 plus 0 over 2, so 4. So velocity is 4 when time is 3.5. You can use math, by the way. You can use y equal to mx plus b, right? Y is of course 8. You have 8. You can have 8. M is you found it negative 8 because acceleration over here is negative 8. So negative 8, x is 3, right? Plus b, so b is 32. So y equal to mx plus b. Y is what are you trying to find? Negative 8, 3.5 plus 32. So y equal to 4. So you can find it many different ways. In this tutorial, I'm going to help you understand every problem at least 2 different ways. I'm really tired, otherwise I would be showing you 5 different ways, but I'll just do it 2 different ways. The 2 car, right? The car 1 is moving faster than car 2. This is moving 20 meter per second. The car 2 moving 50 meter per second. U1, both car meet. If the scenario is like this, the both car will never meet. So you have to give this car a head start for both car to meet. They meet at this point where the time is, let's say, 80 seconds after they both start moving. This d initially is 0. this d initial has to be what, so that they meet over here. Maybe the graph will help you understand better. So now the car 1, of course, car A has a higher slope, right, because it's moved faster. The car B has a lower slope, right, because it moves slower, right? So this must have some d initial, which is over here, so that at 80 second they both meet. So I want to find two things. I want to find x, I want to find maybe y. Okay, actually in the exam I ask you to only find the x, because the car A moves this much entire path from here to y, and the car B moves from here to y. So the car B moves a little bit less than car A. Over here you can set right here, since they both meet, or right there, since they both meet, dA is equal to dB. So this is dA, this is dB. So you can say dA is equal to dB, right? So you have 20t is equal to 15t plus di, right? So 5t is equal to di. So 5 at 80 second, right? So di is 400. Okay, so di is 400. So this x is of course 400. This x is 400, right? So the blue moves only 400 to y. Okay, so how much does it move? 15 times 80 plus 400, so 16. Y is 1600. Okay, 1600. Okay, or 20 times 80 is 1600, right? So the red moves 1600 from 0 to 1600. Blue moves from 400 to 1600. So blue only moves like 1200 meters, while the red moves 1600. Okay, that was problem number 2. Now problem number 3 is the easiest problem, but I had to give you because I expose you to the ideas of Galileo for many days. Okay, so I give this information just to confuse you, and while grading your paper I saw many of you made mistake. If I drop this object over here, right, what would be the impact acceleration? Of course, negative 9.8 meter per second square. Acceleration over here is negative 9.8. Acceleration over here, when it is falling, acceleration is negative. That's what Galileo said. Galileo said acceleration is constant. So their impact acceleration and the initial acceleration, they all are the same, because acceleration is constant. It doesn't depend on who? It doesn't depend on time. So negative 10 would be fine, but those of you who wrote negative 9.8 also fine. Those of you who wrote negative 9.81 also fine. Okay, good. That takes us problem number 4. Problem number 4, I ask you to find the elapsed time, how long the ball was in the air. Many people made mistake. So this is, you can do it two different way. One is 29.4, and this velocity final is negative 29.4. The velocity here at the maximum height is 0. So if you find the time over here, you can multiply this one by 2 and find the time over there. So maybe we can do both way. Maybe we can find this way. Vf is equal to Vi plus At. So Vf is equal to negative 29.4 is equal to 29.4 minus 10 t. So that gives you t is equal to 6 directly over here. T is equal to 6. You can do this way. Vf is equal to Vi plus At. Vf is 0, is equal to 29.4 minus 10t. So t is equal to 3. So if t is equal to 3, 3 plus 3, because this takes 3 seconds, this takes 3 seconds, 3 plus 3 is of course 6. Again, you can do two way, you can do many more way, but since I'm a little tired, I'm not going to show you like 10 ways. I'm just going to be showing you 2 ways to solve every single problem. Downward, many people made mistake with this downward. Downward means negative, so velocity initial is negative 0.5. Okay, and I ask you to do this. So let's draw something called 4 meter above the ground, and you throw down an object, right? You throw down an object from this height, right? Okay, so with initial velocity negative 0.5 meter per second. Of course, what I want at this right here, the ball is now right here, 0.7 second later, right? Okay, so how much above the ball is from the ground, right? How much above the ball is from the ground? Okay, that's all I need to find. To find this, I need to find the length of this red, okay? Or maybe I can say 4 plus d. So this is d. I can call this one d. 4 plus d. 4 plus d. What is d? D is pretty simple. D is a VIT plus half AT square, right? So D is VI is of course negative 0.5, and then this is negative 0.5, and this is 0.7 minus 5.7 square, right? So D is negative 2.8. So 4 minus 2.8, so this is 1.2, right? So this is 1.2 meter. You can do, of course, a different way. You can do using algebra geometry. You can do VT graph. So if you do VT graph, then you have initial velocity, which is right here, minus 0.5, right? And you have object fall with linear velocity. Linear velocity means something like that, and ball falls only 0.7 second. You have a rectangle and you have a triangle. Rectangle is 0.5 times 0.7, 0.5 times 0.7, and triangle is, of course, as you see it over here, you need final velocity. So final velocity Vf is equal to Vi plus At. So you have negative 0.5 plus 10, negative 10, 0.7. So you have negative 7.5, of course. So you have 0.7 base times height, which is negative 7. Okay, because 7.5 minus 0.5 is just negative 7. Okay, good. So if you add this 2, you get negative 2.8. So 4 plus d, so 4, this is 4, right? Minus 2.8, which is 1.2. So again, you get 1.2. That takes us problem number 6. Problem number 6 would be the problem that we did many times in the classroom, right? So you have a basketball player, you have, let's draw, okay, over there as well on the other side, okay. Okay, so from here to here is 30 meter, right? 30 meters, right? Okay, so I'm gonna draw dt graph, and I'll draw eventually vt graph as well. So this is displacement versus time graph, right? And this is vt graph. Okay, so let's do it. This guy goes over here, okay, so I'm going to draw that. This guy come back over here, and I'm going to draw that, okay, and that is 10 second, 10 second, 20 second. Now this guy go over here, I'm going to draw that one. This guy come back over here, I'm going to draw that one, okay. That is 40 seconds. Let's, before I move on, well, I'll do that again. This guy go over here, let's change the color, and this guy move, return back. So this is 60 seconds. So now let's finish this. The velocity, what is the, okay, so what is it? He does go this plus this is 60. he does it 3 times, 180. He spends 60, this is 3. So this is 3, and this is the negative 3. Okay, so the slope of this one is this, okay, and slope of this one is this. Okay, so this is 20. Slope of this one is this, and slope of this one is slope of this, okay, slope of this one is this, and this is 40. Slope of this one is this, and slope of this one is this one is 60. Okay, so if you add them, this is you have, this is 10, right? 10 times 3 is 30. So this is 30, this is 30, so 30, 30, 30, 90. What about this one? This one is 30, this one is negative 30, this one is negative 30, so negative 90. So displacement is 0 and distance is 180, and yeah, distance is 180. Okay, so I didn't ask you to do all those things. All you need to do this, make sure you write 30 over here. Okay, good. So this was problem number 6. Now we're going to do 7 and 8. 2 more problem to go. 7, problem 7, I ask you to, okay, so this is again same problem. You can do algebra and geometry. So d is equal to vit plus half at squared. I ask you to find the total displacement. So d is equal to initial velocity is negative 2. Do not forget that I wrote downward. Downward means initial velocity is negative 2. T is 4 minus plus half negative 10, and 4 squared is 16, right? So d is equal to negative 88 meter. Now we're going to use the geometry to do the same thing. So this is what you call it an initial velocity, which is negative 2, and the ball falls with linear velocity, right? For how long? 4 seconds. So you have the BH, which is negative 2 times 4, which is negative 8, and you have half BH, which is half, B is 4, H is, let's find H, which is velocity final is equal to velocity initial plus 80, negative 2 minus 10, 4, so which is 42, negative 42. So that is negative 40, right? So this is 2, this is 80. This one is negative 80. So then negative 8 and negative 80, negative 88. So these and these are the same. No matter how you do it, you get the same answer. That takes us to the last problem. Okay, so last problem. Okay, so this is our last problem for problem exam number 6. Triangle, half BH, so half B is 3 minus 0, H is 20, plus again triangle, half BH, this time B is 5 minus 3, H is 20, plus again half BH, so half B is 7 minus 5, H is negative 20, plus this time we have a rectangle BH, plus B is 10 minus 7, plus we have half BH, so plus half B is 11 minus 10, and H is negative 20, plus BH, B B is 14 minus 11, H is 0. Okay, all right, so we're gonna add them up. So 30 plus 20 minus 20 minus 60 minus 10 plus 0. So you have to take the absolute value, 30 plus 20 plus 20 plus 60 plus 10, 140, and that is the distance. And the displacement would be this cancel, so negative 70, so displacement would be negative 40. But I ask you for this distance, not displacement. That was exam number 6. A little tired. I'm going to post 100 problem right now to the Google Classroom. Make sure you print them tomorrow. Solve problem number 1 to problem number 25. That would be the test number 7 on Friday.